You all. With COVID and everything, it's been a little while since I've been on stage, so it's nice to do this again. Prior to COVID, when I spent more time giving talks, I would often talk a lot about how things were built from a mechanical sense. And the technical details for a lot of things are very important, and they're interesting, and I've enjoyed them a great deal. But one of the things that I have been seeing in the last couple of years, especially in a role that I've recently moved into, has been I'm starting to get a greater appreciation for the why are we building things. What have we done in the past? How do we arrive at this state? How do we get to the world that we're in today? And so for today's talk, I'm going to talk a little bit about the how Capital One is building a large enterprise scale machine learning ecosystem to drive a lot of the models that many other speakers have spoken about here today. Things like the ability to optimize our growth and improve our ability to service our customers. But I'm also going to talk about some of the things that focused our particular designs, provided constraints, and informed some of our workings. Because when we started going down this journey, one of the things I realized relatively quickly, and I think a lot of the other teams that we have been participating with began to realize is, while there's a great deal in literature and in things that people are talking about, some of the constraints that we're under don't get discussed a great deal, and we have found a lot of interest, and we have found a lot of excitement in getting a better understanding of that, and that's kind of what I'm here to do today. Before I start, just simply because I've gotten bitten by this before, we're a financial firm. I'm not advocating for you in any way, shape, or form to use any of the technologies that I am talking about today. One of the constraints that we're under is that by law, we have to be very careful about what we advocate people to do, and I don't know if any of you are my customers in here, and so as a direct result, if I talk about technology, I'm talking about something that we did, it worked well for us under our specific circumstances, but I'm not advocating that any of you necessarily use this technology one way or the other. Now that I have satisfied my legal team, let's begin. The goal for ML at Capital One is to make sure that we've got the right decision for any decision that it is that we're making at the right time. One of the things, my career is not primarily based inside of the financial industry, and so when I arrived at it, one of the things that I kind of found fascinating was it felt like the future was there, but it wasn't distributed evenly. And so one of the things that we're doing as a part of building an enterprise scale platform for machine learning modeling and deployment is to make sure that the entire company can benefit from shared infrastructure. We, as well as many other banks, rely very heavily on modeling to drive critical decisions, and there is no shortage of these choices. Everything from core financial decisions, risk underwriting, whether or not someone's going to become a customer, all sorts of things like that, become a part of the decisioning frameworks that we're building and the models that we build and tune. And within the firm, we have huge numbers of people with incredibly different levels of expertise in various areas of statistical mechanics, software engineering, and data science at large. And as we think about models, we think about it in a little bit of I would say in a distinct way for a lot of the work that we're doing, in that model development is very time consuming. Model interpretation is still an evolving science. Doing either of those two activities relies on scarce resources, specifically human brains with very specific kinds of training. And complicating all of this is that every single time we build a model, we're effectively creating a tool that enhances human reasoning and human judgment as a form of job aid, but that usage can become dependence. And when you start depending on your tools overly much, you begin to abdicate that judgment. So these are some of the larger modeling constraints that we're under. Financial institutions obviously are regulated. The federal government has very strong opinions on how we conduct our business in very mechanical senses, and they are not shy about sharing those opinions at regular bases, and this is for good reason. Citizenry relies on them for daily functions, and the economic structure as a whole relies on them for liquidity and soundness. One of the things I've learned about financial institutions as a whole is that the largest benefit they provide is liquidity to the market. The fact that I can be here, literally on the other side of the continent from where I normally live, and I can access pretty much all of my money, is incredibly valuable and didn't exist not very long ago. So having that is incredibly important. As a result, risk for us is a primary motivator in pretty much all of the decision making that we do, and it drives almost every choice that we make. The models that we build as a direct result, we're very cognizant of the fact that they're never perfect, and so the primary challenge we have whenever interacting with them is directly making sure that we're able to understand what is happening at pretty much all points of the model development and deployment lifecycle. Model quality, data quality, all of these things can be measured in many, many ways. But one of the things that's incredibly important in a organization as large as ours, as distributed as ours, and that makes as many decisions using models as ours, is making sure that we're able to do these things accurately and consistently across the entire range of the business. Customer needs internal to Capital One for all of our internal data scientists are many and varied. We came to the conclusion not very long ago that, hey, we need to make sure that we have a consistent environment for all of our modeling activities. Many of you, the organizations I'm sure that are represented in the room, have gone through this own transformation of their own, or perhaps were formed under circumstances where that was a realization that had already occurred. But for organizations that hadn't grown up in that particular environment, that is an evolutionary step that they need to take, and it's one that we're doing now. And so in polling a lot of our users, we got a very long list of requirements that they all had, to the point of it being somewhat overwhelming. We distilled that list a little bit more, and it came down functionally to 4 requirements that were universal across the firm. As a user of a centralized modeling ecosystem, they wanted to spend more time doing the work that they are valued for. Statisticians want to spend more time doing statistics, data scientists want to spend more time doing science, and very few people want to spend more time doing operational things. They want to know that whether or not they're working solo or as a part of a group, they want to be able to transition between those two environments as easily as they can for model exploration as well as production deployment. Essentially, remove friction from the process as a whole when attempting to collaborate or attempting to take insights and learnings into a customer-affecting space. They wanted to bring their models to market more rapidly, and they wanted to ensure that the models they brought to market became more effective rapidly as well. And then finally, they wanted to be able to easily maintain those models and monitor their performance. All of this while still using their preferred workflows, tools, and things that they're accustomed to using without assuming any additional responsibilities. This is a very famous picture that I have stolen, and it kind of shows, I think at the end of the day, one of the main challenges that we ran into. There's a lot of people who really care about that very small black box in the middle of the diagram. And then as you move further and further out of that black box, you notice that excitement begins to ebb very quickly. The problem is that when you have 400 different modeling groups running around building models, those modeling groups, unless they're using common centralized infrastructure, will often end up spending the vast majority of their time outside of that little black box in the center because they have to build, maintain, and operate all of the things around it. That is the crux of the problem that we're attempting to solve. Making sure that there's a system that can handle thousands of interactions, transformations, and transactions in a consistent way. The philosophy of scale here, I think, is pretty great for those of you who may or may not be starting this transition on your own. This is the slide that I see most people taking pictures of so they can convince their own decision makers that, hey, this is a thing we should do. Historically, like I said before, we've had a large number of models run by large numbers of teams. It means lots of repetitive work. It means lots of opportunity for intent to not equal execution, and means lots of opportunity to effectively implement the same thing 2 different times in a way that gives you 2 different sets of output. Not great. That is obvious inside of the operational space. The thing that we have found, as I imagine many of you have as well, is that model training also benefits from standardized processes. At the very least, you have an idea of what you're doing, where you're doing it, and how you're doing it, and it is relatively consistent. The other benefit that you have, if you are in a regulated industry where there is a practice around model risk management or operationalized model risk management, is at some point you begin to pre-adjudicate many techniques, practices, and tools in a centralized way, which means that individuals who are inheriting directly from that have already gone through some portion of that adjudication, and you don't have to do it every single time. If operational risk management is a large portion of some of your business, this is incredibly valuable. It cuts a huge amount of time off of your time to market, and it gives your organization as a whole a significantly greater strength of confidence that the models inside of the organization are doing the thing you expect them to be doing. The general loose workflow you see kind of a lot. We have some kind of transaction needs to be done, data and features, models, decisioning logic, and then the most basic thing that we do, and that almost everyone in this room probably sees on a daily basis, is an approve decline decision, especially on a transaction basis. The philosophy that we had here, I think, is very similar to the philosophy that the previous speaker spoke very eloquently about, which is tightening the loop between the ability to iterate rapidly on a problem. And that takes many, many forms. It could be before the time of cause and effect. If you can tighten that loop, you can act very quickly. And then in a larger sense, if you're able to tighten the loop between, hey, we are beginning to build a model, we're optimizing that model, we're deploying it into production, we're observing the effects of whatever action we are taking, we're capable of monitoring it effectively in the long term, and then we're back to identifying what the next task is. Tightening that loop is functionally the way we're measuring whether or not we're having the effect we're looking for. Of course, trying to make something like this available to thousands of users who are currently working with their own tools and in their own environment isn't easy. How do they learn that the service exists? How should they engage it effectively? How do you manage a human-centric change curve? The interesting thing about this is where maybe about 2 years ago I wouldn't have cared about this at all. I am now, unfortunately, able to talk for hours about this topic. It's actually fascinating to me on how incredibly important that is, especially when you're trying to cause like an internal change. But outside of this slide, I'm not going to address it because that's not the point of this talk today, but it is something that's very interesting. If there's anyone in this audience going through this same kind of change curve right now or trying to advocate in your organization for it, I strongly recommend you don't forget this part. People are resistant to change. Human inertia is a very real thing. Making sure people know that there's a service out there is incredibly important, even if your marketplace is not the actual global marketplace itself, even if it's just internal to an organization. That having been said, there are some pretty clear things that we've been centralizing on that have been assisting us in driving the change overall. Clear, well-published, centrally maintained SDKs and libraries for interacting with the platform, ensuring that we are able to produce consistent artifacts. Obviously, you have programmatic reproducibility, but statistical reproducibility is a thing that I would encourage more teams to spend some time racing after as well. Having a unified stack to make sure that the development environment and serving environment from a software perspective are more or less identical is a great thing. It radically reduces time and risk. Incentivizing overall reuse is definitely very powerful, and making sure that you've got support internal to the enterprise. These are all high-level lessons that we've been focusing on as well. But that is probably enough of the admiring of the problem. Let's talk a little bit about the technology that we've been leveraging. One of the things that I think is pretty fantastic in this that we have found is at the bottom of this stack here for kind of a basic block architecture, things become increasingly commoditized. There's a lot of stuff that does things towards the bottom. You start seeing less and less stuff that does things going up towards the top. Part of that, I think, is because as you get closer to the top here, you start looking at things that are highly specific to your individual use cases, business environments, and kind of localized cultures. And the further down you are, the more common these capabilities are, none of which are more obvious than kind of these three, which form the three lower basic block layers. Because I see people starting to grin at me, I'm going to remind everyone that just because I'm talking about technology, I'm not telling you to use it. Kubernetes forms the majority of our infrastructure management capability on the back end. AWS, we're very public about the fact that we're heavily bought into that as our primary cloud provider. But for a couple of reasons, we centralized on Kubeflow for our primary MLOps-driven mechanism and experiment management capability. Why is that the case? There's a couple of reasons for it really at the end of the day. We were pretty happy about the fact that it took an MLOps-based view towards workflow management. Workflow management inside of machine learning, as I'm sure all of you will know, is something that is very personal to many teams and certainly something that people have lots of opinions about. Certainly going up through the late 80s all the way till now, there have been repeated publications of all different types and sorts, MLOps being kind of the latest generational iteration of it, talking about what is the modeling process, what does it look like, and how should people be going through it. Everyone from the DoD to DARPA has espoused at length about what they think the right methodology is. And one of the things we liked about the systems that we're using right now, and Kubeflow in particular, is that it is relatively lightly opinionated. And I know that I say that with some air quotes sitting around it. But it is relatively easy to buy into and buy out of. One of the things that we began to see relatively quickly was that our internal users really focused on wanting a kind of data-centric approach to their model development, placing that as close as possible. And as we began to kind of entertain and solicit different options for managing this capability, one of the things that we started to see was that many of the models in the company, not all of them by any stretch, but many of the models, are effectively modifications of things that kind of are off the shelf to address specific use cases driven specifically by tailored data. Almost every single talk here today has referenced that in some degree. This model is based on something that has been publicly published. We've modified it in some way, maybe making certain kinds of modifications to it, but in general, we're modifying it in general. And so we've primarily focused on making sure that we've got good capabilities around model selection, hyperparameter optimization, and data preparation, all of which Kubeflow gave us in spades in our testing. I think the other thing that we started to see a little bit more is that entertaining this required reusable components that were able to accelerate developers, making sure that we could automate our experiments very quickly across kind of an enterprise-wide scale, and monitoring mechanisms to drive adjustment and reinforcement, all of which requires all sorts of fun and interesting problems that you start getting into around I/O functions, operative data pipelining, and computational assignment. And this leads to fun conversations about queuing theory when you start asking, hey, what workflows are we going to run? How quickly are we going to run them? This is a complex topic. This is probably one of the more detailed diagrams on what the MLOps flow that Kubeflow tends to espouse really looks like when you start blowing out all of the individual steps. And we were pretty interested in making sure that we were able to support that directly from an infrastructural level. Like I said before, it met a convincing number of our needs. And between the fact that it kind of met what we wanted and the fact that there's strong ecosystem support around it, we've used it fairly heavily for a lot of the mechanics that we have, and have been by and large pretty happy with it. One of the things that I think it could do a little bit better at, however, is we've had to develop out our own monitoring and risk management capabilities for it. One of the most important aspects of that is lineage and provenance. What are the things you did to data before you committed to a decision? Where did that decision go? And more importantly, if you're building a model, how did you arrive at it? Model cards on the left-hand side here, or excuse me, the right-hand side of the diagram is one of the industry standard ways that people look at and think about these things. But it's surprisingly difficult to find off-the-shelf technology that automates the creation of these model cards. And so that's something that we've had to build ourselves internally, between a mixture of annotation inside of source code that we ask our developers to be able to add so that we can develop them internally, as well as static code analysis. We think we've found a reasonable solution for it. But the other thing that we've actually spent significantly more time about is developing out workflow cards as well, which is something that we're beginning to find is probably more impactful outside of a model-based perspective, but inside of a reproducibility and verification perspective. Your model is ultimately the end result of an extended process that you can describe as a DAG, as a workflow, however you want to think about it. We've spent a lot of time, I think, as an industry focusing very, very closely on explainability for our models, reproducibility for our models, but the workflow as a whole is a surprisingly brittle object, is something that we've begun to find certainly internally. And once you start scaling beyond a single team, once you have hundreds, if not thousands, if not tens of thousands of these workflows, you begin to realize just how brittle they can be, how difficult it is to version and track them, and how important it is to make sure that there's a sizable quantity of metadata that can be accessed, indexed, and cross-referenced. It sounds like an easy problem. It generally, we have found, is not. You get to have all sorts of fun and interesting conversations about graph isomorphism and similarity. It turns into a very complicated discussion. And one of the things that we found is that either it's not treated at all in certain aspects of literature and open source technology, or ultimately people throw up their hands and say, define your DAG as a YAML file, Git will do the diffing, and we're going to abdicate our responsibilities in this area. That brings us to what happens after model training, serving in CI/CD, equally important processes. At the end of the day, there's a developer speed and execution efficiency trade-off that we began to see multiple years ago, which is developers, specifically model developers, would begin by proof of concepting their capabilities inside of a notebook, and then at some point they would hand that notebook off to a technical team, and that technical team would do something, and there would be a big question mark, and suddenly a production grade instance, associated pipeline, and model would appear on the other side. And then production grade started to get quotation marks placed around it, and there was much strife. Notebooks are great, notebooks are easy to work with, but at some point you start seeing a skills gap that if they don't cause, at some point they do start encouraging or hiding, is something that I think I have a opinionated statement for. We've done a lot of work inside of our CI/CD pipeline to automate more of the guardrails, automatically extracting metadata information from notebooks, spending significantly more time in the area of validation, code quality checking, and vulnerability management to make sure that we can de-risk some aspects of notebook-based development, and doing a few other things to make sure that our CI/CD pipeline is as clean as possible. This led to some improvements in iteration speed because it allowed developers to work more inside of native tools for a little bit longer, and it has driven some meaningful cultural change. Code quality is a highly opinionated thing. For most groups, I think I found in my experience, they start with linters, and then if they're lucky, they evolve beyond that. I happen to be a big fan of that particular product over there. It is open source. The company who builds it also has paid options, which I have no opinions on. But SemGrep is a pretty interesting tool that allows you to write code that is very similar to the source code that you want to analyze. So if you are writing Python, you write something that looks very similar to Python and extrapolates out to be able to parse a statically compiled AST, which gives you the ability to identify individual patterns, concerns, and things that you want to keep an eye on. It's used in a lot of security mechanisms. You often see this powering some of the more modern static code analysis tools that are used for security. But it's incredibly powerful for identifying all sorts of interesting anti-patterns and general case problems that individuals who are not as concerned with production armoring their code as they are with developing out powerful insights to drive business decisions will often accidentally commit. Moving a little bit further up the stack, the experiment management system as well was something that we were able to leverage a good bit from inside of Kubeflow, but a couple of years ago the company built and open sourced its own solution that is not specifically bound to the execution environment. It's called Rubicon. You can find it on GitHub. It's an experiment management solution that specifically focused on making sure that we were able to tighten that overall experimental loop from really two perspectives. Being able, one, to directly track how the model was evolving as modifications were made to it, outside of just simple hyperparameter optimization, but more importantly, two, because many of the models that we specifically leverage are very long-lived in terms of the lifespan of the underlying model itself, and not individualistic alterations to it. We would often find that developers would onboard onto the project, develop a model, leave the project, and then we had a significant amount of time that came when a new developer would onboard and we'd have to teach them what was going on. We ended up developing Rubicon specifically for the purpose of being able to massively accelerate that process because we had a tracked experimental log of every single time the code was executed, compiled, or an artifact was generated, which was very, very helpful. I think the last portion here around this is probably the area that we've actually found the least amount of help inside of off-the-shelf capabilities, which is monitoring. Internal to our environment, and I would imagine the environments of many other regulated industries, you functionally have this model called separation of duties that divides between things for accountability, right? You have people who are developing those models. You have a set of people who are supposed to be building out the production-grade system for it and performing actual actions to things like that. And then you have business analysts who may action individual insights from there. This is a model that I don't think anyone's particularly excited about and is an artifact of a regulated space and perhaps a different set of normalized culture artifacts that exist inside of, like, for example, financial industries and other regulated firms. And so it definitely looks a little antiquated if you are a member of a more modern tech-first oriented company. But the important bar at the top here that I think would exist regardless is that layer of independent validation. How do you allow a third party, even if they're employed by the organization, but someone who's outside of the model development team, to come in and validate the model's efficacy under a set of scenarios? This is all a part of the overall risk management process that we have been working within. And risk, you can never really prevent it at some level, but you can manage how you deal with it. And one of the things that we've been looking at is an overall treatment of that risk that declares model failures anytime a model takes an action or has an outcome that is in any way inconsistent with its intent. And we treat that as the realization of that risk, which functionally means that if bad data gets into the system and the model makes a misclassification, the model misclassifies anything, quite frankly, in any way, and we identify that as erroneous later on, or any aspect of the system at all displays forms of instability that affect the model's capability to operationally execute, all of those have to be tracked as an aspect of realization of risk. And so we have had to develop kind of a from the ground up monitoring capability that specifically allows us to focus on every step of model development, from the original training to production inference to finally the actual effects the model has on customers. This is very similar to kind of that operational loop that the previous speaker spoke about, but driven by a different set of requirements, which is something we found fairly interesting. The material here is pretty great. There's a lot of work that's been done, I think, by financial firms and regulated firms that, for whatever reason, hasn't really trickled into the open source community. It's a conversation that I have a lot when taking a look at academic publications that talk a little bit about, hey, how are we monitoring models in real time? I think it's a question of, I think my main criticism of the community as a whole is that it seems a little shallow in a lot of the work that I read and a lot of the projects that I review, focused primarily on statistical monitoring, when there is a more holistic body of work that I think needs to be considered to look at the overall efficacy of the model and the system that is around it. There we go. And so as a result, we've developed a system that primarily focuses on statistics gathering across the entirety of the pipeline and the outcome decisions that are driven by model inference, focused on inputs, outputs, and choices that get made. So far, we're tracking those inferences fairly effectively. The inferences are objects in and of themselves, and it requires kind of this large amount of logging and standardized libraries, and it's in its own way in somewhat nascent forms, but it is an interesting effect, and where it's been deployed so far, we're seeing some meaningful results that we haven't been able to replicate in other ways. I know that I've kind of breezed through different aspects of the talk, and I imagine that this is a little bit different than many of the talks that were provided today, so I'm interested to see what kind of questions I get afterwards. But I think the overall summary of the project for us has been, outside of managing the change curve of deploying a system of this size inside of a large organization, one of the things that we've been identifying is that while the ML ops lifecycle is very well supported, or at least robustly supported, I would say, inside of many technologies that are out and available today, I think that some of the tracking, versioning, and monitoring capabilities for various stages of the life cycle are perhaps a little bit weaker or not quite as focused on in a couple of other areas. Tuning, model and experiment versioning, I think, is all mature and it's supported by a lot of different offerings. But I think that the pipeline versioning capability is still largely frustrating to say nothing of being able to split out and manage large numbers of these artifacts that are being used by multiple groups. If you don't have a strong versioning system on the inside, you end up having a great deal of unnecessary duplication. It becomes non-discoverable, not because you haven't indexed it, not because it's not available to you, but because it's almost impossible to differentiate between version 1, version 2, and fork number 50 of a particular capability or pipeline. And that introduces its own kind of operational risk. I think the last insight that I think we've primarily had is when operating in this space, even as more and more capabilities of this increasingly increasingly commoditized stack become developed, robust, and have a great deal of support put around them, I do think that there are still gaps, certainly as you climb the overall stack, to be able to be supported in more and more environments that are larger, have a greater diversity of users, and perhaps even some unique needs in the area of risk. I wish I could tell you that there are conclusive answers in this particular area for that, but unfortunately I think that much like the FAA often says, many of the rules get written in blood. You only find these things out afterwards, and we don't talk enough about our failures. And so when preparing for this talk, I wanted to spend a little bit of time at least discussing that particular body of challenges. One of the things that I'm increasingly noticing while I stand up here is that I don't actually see a clock, so I don't know if I have wildly blown through my time or if I'm ending 20 minutes early, but I will turn this time over now for questions, debate, throwing things at me because you think I have in some way insulted everyone in the room. I am excited to hear what comes of it. Thank you all.
Thank you. Questions?
Thank you very much for this great overview. So I'm Alexei Krabov. I run multiple developer meetups in the Bay Area, and we had a lot of folks from Capital One presenting on Scala. We hosted some tutorials there, so we know Capital One is a great open source organization. I wonder, right, you mentioned some topics. Now I work for IBM, and I think there are similar things I noticed, like there is a big siloed organization, different pieces are doing different things, right? So, and if you want to, for instance, introduce reuse, right, a very typical situation is that, multiple teams may be doing the same thing, right, but they respond to different divisions. The incentives are not aligned. Normally, you would want them to work on, not reinvent the wheel, but some people think that rectangular wheels are better or triangular wheels are better, right? So how do you, do you have power to look across the organization, and what kind of structures can you institute to facilitate reuse? That's number one question. Second, I'm just curious, right? Like you kind of stop short of the actual business case because it's financial industry is very secretive, and I found it's very hard. How do you fuse open source with secretive financial culture? Is there any way to pull out things like hire, like decision making? Can you share some interesting problems, make people contribute to them through open source, or it's just kind of stops because of secrecy at some threshold?
So before the mic moves from you, you've asked me two questions. I will probably have to double back and ask you what the first one was in a moment because I have the memory of a goldfish. So the second question that you asked is really interesting. I interpreted that primarily as your business model as a whole can at the surface appear to be in conflict with many of the cultural norms of open source technologies, and certainly probably the development environment in which open source is developed, right? That is less of a challenge than I think it used to be, which is a great statement. Speaking specifically about the organization I'm representing today, Capital One went through kind of a very large cultural change in that maybe about 10 years ago before I had joined the company. And so there was a great deal of focus on making sure that that could happen. We have a great number of controls internally, primarily governed through, hey, what kind of telemetry we allow outside of the organization, which is extremely aggressive. One of the big benefits of many open source technologies is there's a limitation on what telemetry tries to sneak its way in. There isn't quite the same profit motive there that leads to that kind of thing, which is pretty great. But from a cultural angle, I would say that is a transformation that has been undergone, I think, it's going through the industry as a whole more rapidly, right? From a business case for open source in general, to put it as bluntly as possible, we're a bank. Our product isn't the technology. Technology is a direct line enabler, right? For anything that we're able to use, leverage, and not have to develop ourselves internally, that's a significantly lower amount of risk that we carry, quite frankly, because every line of code is risk. And then two, it is a capability that we're able to continuously leverage and benefit from, right? We do try to fund a fair number of open source communities, do the give back style thing, but from a business perspective, the case for open source tech in general is increasingly clear cut these days, which is a great thing, right? Even in organizations that I think, like a financial institution, can be very risk conservative, that hasn't been too much of a challenge. And you're seeing this spread very quickly through the industry as banks measure time. The business case for the system as a whole is a more common, easily managed, and easily introspected environment, reduces risk overall, increases the reliability of the models that we produce, and generally makes the business faster and safer. That's the premise. And so that business case also writes itself fairly effectively. Your first question, however, was one that I've actually never seen before at a talk, which effectively, as I interpreted it, came down to, hey, do you have the visibility necessary to ensure that there isn't duplication? Because humans are often rewarded for building the new thing, not reusing something that currently exists. Without having me stand on stage and whinge philosophically about the human condition, which probably is not going to benefit anyone, the thing that I will say is this. That is going to be a challenge no matter where you are, no matter what you're doing, and no matter what you build. But it transitions from being an inaccessible challenge to being an accessible one when you begin collecting, centralizing, and getting visibility into what those components, libraries, and systems are, taking ownership of them internally, where possible, right, to make sure that at least clear, unambiguous common capabilities are centrally owned and are able to be driven from a central place of intent. And then two, it becomes a mechanism where at some point you stop fighting the technical battle or the visibility battle, and it becomes simply the culture battle, right? Driving that change across the organization requires rethinking the way we incentivize things, highlighting what levels of reuse we're observing and where the reuse is happening and being occurred, and rewarding people for contributing to common capabilities and shared projects. That may be an unsatisfying answer, but like unfortunately, it's the best I can do.
Right? Yeah. Like collect the data, then make it speak for itself. That's actually very reasonable.
If I had a silver bullet for how to solve problems of differentiated incentives, I'm pretty sure that my general station in life would be very different.
But do you have any org, any office at Capital One, which job it is to look across?
That is a part of the risk offices. There's an organization called the Model Risk Office, which focuses primarily on keeping large inventories of models. Their role is beginning to change powered by systems like this, and that provides a soft mechanism to drive this kind of change. Because then you're able to say, well, okay, how are you accessing this data? How are you performing these transformations? How are you building this pipeline? Oh, you're using something that has been adjudicated in the past in a very formal way. Great, we don't have to do that anymore. And suddenly you get a significantly improved process.
Cool. Yeah, makes sense.
Anything else?
Hi, I have one question about the data versioning you talk about in the summary. Are you referring to data versioning or more like data governance? Because the sentence forward, following that, it's talking more about like user access. The reality is that we did abide by a couple of data issues, is that we tried to train machine learning models using some data, but the upstream, let's say upstream, they changed the definition of certain kind of data, or maybe there's some bug introduced in these pipelines. And it's really difficult to propagate this type of information to the downstream user, especially machine learning models. And then that actually caused either our model, the training data and the test data is just like does not match with each other, or simply the data was wrong. So do you have any insight, like any open source tool can help like manage this type of issues?
DBT makes certain things better, but it's not a point-and-click solution, unfortunately. I would say that it, like many other open source tools that I've worked with in this particular area, works really great for a single team or a single relatively unified group. The bigger that group becomes, you start seeing that these tools break down, not because they can't scale from a technical perspective, but because their access models and the models of how they think about collaboration capabilities starts to get a little bit weedier, if that makes sense. I think that right now, the world that we're in is everyone's growing their own solutions. We're all solving it locally, right? I really wish I was able to look at you and tell you, oh yeah, no, we've got the thing, right? But everyone's growing their own solutions right now, specifically in the area of data versioning. But the other area that I think is really important here, I would suggest that up and downstream effects management is a part of governance. It's probably not always the part of governance people talk about. Obviously, inside of the summary that I had, you notice the discrepancy in the language, which is a fault of mine. I'm not the best writer. Effectively communicating, hey, we're thinking about this in terms of access, but I would suggest that it actually goes significantly beyond that, because the other side of versioning is communication and response. I've made a change. There's now a version 2. Do I push version 2 of that data, of that schema, of whatever it is, down to my downstream? If I push it, are they going to accept it? Do they need to be that robust? Is it a pull model? All of that material, I think, at least internally, we have been modeling as a part of overall governance issues, for lack of kind of better, big, large bucket language. Policy gets written around that sort of thing. From technical perspectives, pretty much everyone is writing their own thing as far as my knowledge is. If anyone knows of a solution that's like widely available or at least widely discussed, I'd love to know. I can't begin to tell you the number of hours I've spent trying to find write-ups, conference talks, anything about details, and it does tend to get locked up inside as a part of local intellectual property. That's probably the more generous interpretation. I think the less generous interpretation is everyone realizes that, it's not something that they're proud enough to talk about, and so they don't. But like that, I think that is a global problem right now, and I'd love to see anyone with a solution to it.
Just curious, like, is there any tool available to manage the data dependency, or like for software engineering, we have these libraries.
Yeah.
Like every library has a version, and then when you compile, you immediately have build a dependency graph and trying to see whether there's a conflict. I wonder, given that we are so data heavy, I thought there should be some tool trying to manage it.
I agree with you, right? And I know that, oh, how embarrassing, the name of the group just got from me. The people who make Kafka. They have a schema registry that they publish publicly, and it's this large project. But I still feel like systems like that are just the first step, right? The ability to immediately solve the push versus pull debate, the ability to register those schemas, the ability to actually find individual fields and capabilities for it, and individual records that respect individual schemas is all very important. To say nothing of the challenges you run into when you start doing historical backtesting, and then you go far enough back and you start changing schema versions with a model that may not necessarily be aware of that. I do think it needs to exist, but I think there's multiple components that is an ecosystem unto itself, which I think is why it has been so challenging for so many groups. There might be capabilities that solve piecemeal parts of it, but making them all work together as a cohesive whole is not something that I think the community as a whole has centralized around, even like a firm language for it, to be perfectly frank.
Great. Thank you so much, Zachary. That was wonderful.
Thank you all.
Appreciate it.